Hello everyone. This lesson is about limits and piecewise functions. So far we've done limits on graphs, we've done limits with 0 over 0, and now we're going to do limits, we've also done limits with a number over 0, and now we're going to do limits if we have a piecewise function. If you forgot what piecewise functions are, they're functions made up of two or three or multiple other smaller functions. So a piecewise function could be a function with 2 functions, or a function with 5 functions, or a function with 10 functions. It's just a function made up of smaller pieces. So when we find the limits, it's very important that we look at where is the limit, where is it located, which piece is it located at, and then plug in the number. So here's my piecewise function first, f of x, and it's made up of 3 different functions. 2x over x plus 5 squared, x squared minus x over x, square root of 2x plus 1. This function is for all numbers less than -3. This one is for all numbers between -3 and 4. And this one is for all numbers greater than 4. So let's start off with this -5. I have -5 general, -5 minus, and -5 plus. As you can see, -5 would fall under one of these 3 pieces. -5 would fall under this piece because it is less than -3. Because it is not a breakpoint is a number that is located here. So I have a breakpoint at -3 and I have a breakpoint at 4. If you do not have a breakpoint, like this is not a breakpoint, -5 is not one of these numbers, all I have to do is plug in -5 and it'll be same for all 3 answers. So what I'm going to do is I'm going to plug in -5 into this first one. So I'll write it in over here. So 2 times -5 over -5 plus 5 squared. I get -10 over 0. So this is sort of a review now. I have -10 over 0. You notice that nothing cancels, so I have a number over 0. Now I gotta do something from the left and the right. This is -5 minus and -5 plus, so I'll do -5 minus. I'll do my little table. And I already know my numerator is negative. Now I gotta do the denominator. A number that is -5 minus, the easiest one to do would be -6. And the easiest one for -5 plus, I would say, is -4. So now, all I gotta do is plug in these numbers and see what type of sign do I have in the denominator. If I put a -6 in the denominator, -6 plus 5 is -1. -1 squared is positive. So if I plug in a -6, I get positive in the denominator. -4, if I plug in -4 here, -4 plus 5 is 1. 1 squared is 1. It's also positive. So remember, the answer is infinity because of a number over 0. On the left, I have what type of infinity? Negative infinity. On the right, what type of infinity do I have? Also negative infinity. So if the right is negative infinity, the left is negative infinity, that means the general limit is negative infinity. Okay. Let's try a different scenario. What if, for example, I have, what if, for example, I have -3? So let me just scroll down real quick. So now let's look at a situation where the number is chosen is a breakpoint. So here we have x goes to -3. We also have -3 minus and -3 plus. Now you'll notice that -3 is a breakpoint because -3 exists here and here. So that tells me that I have to try to find the left and the right first. So here you notice I'm going to try -3 minus first. Which one do you think represents -3 minus? Is it this one or this one? -3 minus. Yeah, it's this one. Because this one represents all numbers less than -3. So that's -3 minus. So what I'm going to do is I'm going to plug in -3 into that function. So I'll write it down here. 2 times -3. Oops. Sorry about that. Two times -3 over -3 plus 5 squared. And if I do this, I get -6 over 4. If I reduce that, I get -3 over 2. So now I've done the left side. Now for -3 plus, I'm going to try to find the one that represents negative 3 plus, which is this one, and plug in negative 3. So let's plug in negative 3. I get negative 3 squared minus a negative 3 all over negative 3. I get 9 plus 3 over negative 3, which is 12 over negative 3, or negative 4. Now, from the right is negative 4, from the left is negative 3 over 2, which means the general limit does not exist. It's zooming in again. Alright, so this one does not exist. Okay. Now, let's try another one. This one says 0. So if I want to try 0, again, I need to find which piece does 0 fit in. Is 0 less than negative 3? Is 0 between negative 3 and 4? Or is 0 greater than 4? Yeah, 0 is in between these two. So what that tells me to do is plug in 0. It's not a breakpoint, so all I have to do is plug it into this one. When I plug in 0, I get 0 minus 0 over 0. Now I have a 0 over 0 case. Remember what we did when we have 0 over 0? Yeah, we had to factor or rationalize or simplify a fraction. In this case, you may notice that I could factor my numerator. So I could take out an x. And when I take out an x, they cancel top and bottom. So this whole problem is just x minus 1. So now I'll plug in 0. And if I plug in 0, I get negative 1. And again, because this is not a breakpoint, 0 is not a breakpoint, it will be the same answer for all three. From the left is negative 1, the right is negative 1, and the left is negative 1. Because it is not a breakpoint. In this case, it was a breakpoint, so I had to try left and right and also the middle. In this first case, because I got a number over 0, I had to test negative and positive before I found the general. But this case was not a breakpoint, and it was not a number over 0. It wasn't an infinity. That's why I was allowed to do that. So now let's try a little bit more examples. Let's look at 2 more. How about 4? Is 4 a breakpoint? Yeah, 4 is a breakpoint. So if 4 is a breakpoint, that means I have to try from the left and the right. This one represents 4 minus. So all I'm going to do is plug in 4. If I plug in 4, I get 4 squared minus 4 over 4, which is 16 minus 4, which is 12, over 4, and I get 3. So let me scroll down and plug in 3.